Kia ora and welcome to this short little video on absolute dating. Today we're going to describe how radioactive decay occurs, look into how this relates to dating of rock, and identify four main types of this radiometric dating, and finally determine the best type of radiometric dating to use for the particular thing you are dating. So without further ado, let's move on. Alright, let's just recap last video. We looked at relative dating. Today we're looking at absolute dating. So relative dating was looking at different variations or unconformities within the rock to gauge when and where and how old rock is, and looking at different fossils within those rocks to try and gauge a date. This is a little bit more of a specific dating method that gives us a lot more accuracy. So we'll uncover that now. But before, we need to go over a few things. So absolute dating is any method of measuring the age of an event or object in years specifically. To determine the absolute ages of fossils and rocks, scientists analyze isotopes of radioactive elements. So those are two things we're going to unpack in this video here. Isotopes are atoms of the same element that have a different number of protons, have the same number of protons, but different number of neutrons. Okay, so I'll say it again. The atoms of the same element that have the same number of protons, but a different number of neutrons. Okay, really important to remember. All right, so moving on. Most isotopes are stable, meaning that they stay in their original form and they don't change. Scientists call unstable isotopes radioactive, and you would have all heard that term. Maybe you've watched Chernobyl or something and seen what radioactive material can do to people. However, it can be used for dating, which isn't such a bad thing. So radioactive isotopes tend to break down into stable isotopes of the same or other elements. Because radioactive decay occurs at a steady rate, scientists can use the relative amounts of stable and unstable isotopes present in an object to determine the object's age, which is what we're going to be doing here today. So if you look here, we've got an unstable isotope which has 6 protons and 8 neutrons, and remembering what we said before, you can get different variations of that. When radioactive decay occurs, some of those isotopes will decay and a neutron will be converted into a proton, which in the process releases an electron, and then we get a stable isotope where the protons and neutrons are balanced. Okay? Cool. So, you might have heard me talk about these. These are two words we need to get our heads around. So, in radioactive decay, an unstable radioactive isotope of one element breaks down into the stable version of another, and that stable isotope may be of the same element or different. When this happens, we call the original unstable radioactive isotope the parent isotope, and we call the one that it changes into the stable isotope that is produced by this radioactive decay called the daughter isotope, so parent to daughter. Okay. Here is the rate of radioactive decay, and we said before that it is constant, and this is why scientists can compare the amount of material, parent material there was, with the amount of daughter material in the rock, and the difference between those two is what allows us to see the age of a rock. The more daughter material that is there, the older the rock, because it's had longer to change from parent into daughter. So the more daughter isotopes that are there, the older the rock. And we can see that here. Now, you would have noticed something in that graph, and that is that with radiometric dating, which determines the absolute age of a sample based on the ratio of parent material to daughter material, you would have seen that it has a very specific pattern, which is highlighted in this diagram as well. If you know the rate of decay of a radioactive element in a rock, you can figure out the absolute age of the rock. The half-life, and you might have heard that before, it's not just a video game, the time needed for half of the sample of a radioactive substance to undergo radioactive decay. Okay, so that's a constant number, and if you know the element that you're dealing with, you can work that out, and that is the fixed time that it takes from a full 100% of the parent isotope to convert into 50-50, and then it will take that much time again to convert fully half again, and then half again. So we keep getting smaller by half each time. So scientists use different radiometric dating methods based on the estimated age of the object. So they look at an object and they go, right, this could be this old, so we're going to use this method. And there are 4 types. So I'm going to go through them now and tell you what the parent isotope is and what it converts into in terms of the daughter isotope. So we've got the potassium-argon method. So we have potassium-40 has a half-life of 1.3 billion years to go from 100% to 50%. And it decays, leaving a daughter material of argon. This method is used mainly to date rocks older than 100,000 years. Okay? You may have heard of this one when we looked at that documentary at the start of the topic, but uranium-lead method. So we look at uranium-238, and this is a radioactive isotope with a half-life of 4.5 billion years. So it takes a long time to decay. Uranium-238 decays in a series of steps, which leads to lead-206. The uranium-lead method can be used to date rocks more than 10 million years old. We've got the rubidium to strontium method. The unstable parent isotope of the rubidium-87 forms a stable daughter isotope of strontium-87. The half-life of the rubidium-87 is 49 billion years. Okay, this method is used to date rocks older than 10 million years. And finally, you may have heard this, the carbon method, okay, or carbon-14 method. This is, so carbon's normally found in 3 forms. We've got the stable carbon-12 and 13, and then we have a radioactive isotope called carbon-14. Living plants and animals contain a constant ratio of carbon-14 to carbon-12. And once a plant or animal dies, no new carbon is taken in. So the amount of carbon-14 begins to decrease as the plant or animal decays. The half-life of carbon-14 is 5,730 years, so a bit more specific than the other ones. The carbon-14 method of radiometric dating is used mainly for dating things that lived within the last 50,000 years. You've heard a bit of controversy with these dating methods of using the wrong ones. So now they've got more variety of methods, and if they use the right ones for the right object, we get an accurate roundabout date of when this rock may have been formed and how old it is. So what have we learned about today? Going back to this slide here, we now hopefully can describe radioactive decay and how it occurs. We can explain how this relates to dating methods for rocks, and we can identify the 4 main types and what objects to use those on to date them. So I hope you have enjoyed this little video. Make sure you grab the sheet to fill in answering some questions.